Year 1959, molten iron flowed from Parvati, the first blast furnace of the first integrated steel plant in the public sector at Rourkela. It was followed by the second plant at Bhilai the very next day. The third plant at Durgapur also went on stream the same year. Thus began a new era 60 years ago, an era of progress, an era of self-reliance, an era of turning sleepy towns into bustling steel cities, an era of building a new India. Obscure places in India's inaccessible rural heartland transformed into landmarks that punctuated the country's length and breadth. True temples of modern India thus emerged from nothing but green fields and brown earth. Steel Authority of India Limited.
Inspiration for our website Sale Vistar for our solution was taken from the official website of Sale, to closely resemble the existing platform, so that the solution Sale Vistar looks like an existing part of the sale pro- pipeline, and it's easy to implement later on as well. Along with that, the booklet that is also available on the official website itself was also thoroughly read through for context awareness and understanding better how sale works and what exactly the history of sale is and what sale also plans on aiming. Let's move on to understanding our ML models far better. We estimate shipment delay for each candidate route. This helps the optimizer balance cost versus SLA risk. We will discuss the data and features in more detail now. We train on a compact tabular data from cost, yield rate, handling fee, and base cost from cost.df. Inline demo data comes from our core data node inline data, like seen here. Realistic fees can be loaded via data model realistic models we use random forest regressor in core model.mopi like seen here, and trained linear model is been implemented here, used for a fast robust average relay signal for uncertainty. Three quantile models, fifth, 50th, and 90th, trained on services MLSPC main.py, like seen here with gradient post regression, loss is equal to quantile basis. This gives a distribution view of DB. This is a whole ML model for the same. Now, serving and endpoints on Starter. The ML service forms a model from inline data that exposes post-predict and post-predict quantiles for point and quantile predictions, post-train and post-train scheduled for retraining and workflow, get metrics and model, meaning the RMSE, sample counts and get monitor driven features and shifts. These come under the serving and endpoints in our model. Now let's look into how the optimizer uses it. The optimizer calls core ML UI predict route delay with uncertainty, which its predict quantize. It builds a sampler per route from Q05, Q050, and Q95, enabling scenario runs and risk methods, example CDAI. Now let's look into versioning and artifacts. Train pointer models are saved under mobs. We can see here there's metadata, JSON, and the three different PKX. The front end shows metrics on web pages, model metrics, TCS. And for the governance, we track model metrics and data drift in the UI. Retraining time is scheduled and each version is stored with metadata traceability. By building the system, it makes sure that while scaling it in further into different ports and softwares, it will be easier to implement those data in the existing one and existing model solution. Now let's take a front end overview. Next.js React app under web folder with undesigned UI floppy charts. HTS for API calls, pages live and web pages folder. Layout and navigation is seen here. Global header with logo that is we've we've made use of this logo in our website itself. We will see it further. And we've used sticky top and main navigation links to the routes. Wraps up all the pages with authentication web components authentication. See it in full. Seen here. And these tokens from web art. It takes tokens from here. Such global styles and a tricolor tagline. We will put that in the web. Now let's look into the dashboard. Controls for optimization rates, toggles, that is cost, SLA utilization, priority, multi-destination, and allow roles, etc. Toggles for optimize. Calls the code optimize, then shows KPIs, recommendations, constraints, cost playground, Pareto, route visuals, and etc. Now the environmental part from the environment metrics, CO2 saved reduction percent is also shown on the web app. Users React state for figures and design for layout. We've tried to keep the architecture and stack very optimal and use case friendly. Model and optimization metrics fetches from services on mount with ACS. Now, the different ports that are 801, 8001, 8002, and 8000 metrics model that are three different model metrics for four model stats, features, edge shifts, and recent optimization runs. Builds a plotly scatter of solve time over created uses dynamic import for swiftly. Now let's understand the data flow. UI reads data sets via the data sets in code 2000. This is our data sets. We've built dummy data considering all the routes, rail rate, handling fee, base cost, and average delay per hour. These are the different data set columns and rows. um, Generated the dummy data, taking in consideration the historical data, different research files, and different content available across the web in order to save infrastructure, web, and historical fact. This is the data. We've compiled over 5,000 data columns for the same. Now let's understand the UX patterns and design components for responsive layout closely for charts. Issues error handling via message errors where relevant. All service URLs are local at 848,000, data API at 8001, and optimizer at 8002 along with M. you can overview of the backend and understand the architecture. Now, starting with the three fast API services behind the Next.js UI web. Services Data API works on server port 8000. Serves datasets, destinations, mastered and authentication and authorization. Services and Optimizer SVC runs on port 8001, runs the multi-objective optimizer and exposes run history and metrics. Services ML SVC runs on port 8002, screens and serves delay models and model governance, that is metrics plus risk. Now let's understand the data APIs better. Get data sets with their datasets unified payload, combining orders, inventory, variance, cost, forecast, and lessons. Post data, post datasets uploads that makes use of partial replacement, validation, feedback. Get destination, post destination, and upload destination master for view coverage. We will see that on the UI front end. Authentication, post authentication, login, get authorization for who. We have architected this so that multi-role authentication is also integrated. This also supports data more realistically load CSVs from data heuristic samples. For example, if you want to load your data from your SAP server or SAP environment into this, or sometimes direct Excel sheets, this works in those terms as well. And let's understand optimizer. So this is an optimizer part. Post optimize accepts weights and flags, example weight cost, weight SLA, weight multi destination, allow load selection, and etc. These are the different parameters you have to keep in mind. And get runs and get runs meters. This takes care of recent runs plus sort time, model version, and sharps snapshot as well. Get metrics. It aggregates optimization KPIs and get metric environments takes the concerns of CO2s and fuel savings. Now let's look into MLSPC. This warms the RF model on startup using inline cost. Post-train schedule takes care of trained RS plus quantile models, stores version artifacts under models like you can see here in the same three PKs. Get metrics models, MAE, RMSE, and sample counts, features and chips. We can get the health codes on get health, how it flows. UI fetches get data sets and then user sets the weights. UI calls, that is post optimize. Optimizer consults ML via the code predict route delay with uncertainty model to capture this context and then results. And then we can get the results plus metrics feedback to UI, that is dashboard cards, which is very certain this part of our